All right, now we're going to move on and look at some of the exponent rules that are used when simplifying expressions. We're going to need this when we get to working with scientific notation. All right, so if we were to multiply x to the second times, if we're going to simplify x to the second times x to the third, x to the second we know means x times x. X to the third means x times itself 3 times. So if we were multiplying all of that, we'd get x to the 5th power. All right, now that can be done to remind us or to show us what the shortcut rule would be that you could use. So notice I could have gotten the 5 by just adding the exponents. That's going to be okay to do. That's going to work all the time when you have two expressions that have the same base, like these both have an a. These both have an a. When you have two expressions that have the same base like that, what you can do, it would be the base raised to m plus n. Okay? Now it's easy to get that confused. That's called the product rule. It's easy to get that confused with the power rule. Okay? With the power rule, we can figure out what the rule is by using this example. Okay? The exponent of 3 would mean that x to the second would get multiplied by itself 3 times. So you have 2x's times 2 more x's times 2 more x's. So you really have a total of 6 x's multiplied together. So that would be x to the 6th. So the shortcut rule for this is actually going to be that you could multiply exponents. So notice on this that you have a power. It's called the power rule because you have a power being raised to something. Okay? So that the parenthesis kind of cuts between the two exponents. That's the case where you could multiply the exponents. But up here, see how the base is written in both cases? So you have the same base and you're multiplying, you can add exponents. Okay? Now one more would be this one, the quotient rule. Let's see, I gotta move over a little bit. All right, so for the quotient rule, it's kind of equates to what happened with the product rule. X to the 5th would be 5 x's multiplied together. X to the second would be 2. And isn't any number divided by itself going to equal 1? So that would equal 1, that would equal 1. See, we can knock out 2 of the exponents, 2 of the x's, and what we're left with is an x, and it would be raised to the 3rd power. Now look back at what the original exponents would be. Okay, so that seems to suggest that what we could have done is just taken the 5 and subtracted the 2. Just taken the x and raise it to the 5 minus 2 power. Okay, so this is just one example that you can use to remind yourself of what the rule is, but this rule really does work in all cases. Okay, so it's always, if you have two powers, two expressions with the same base like that, then the answer could be found by doing a raised to the m minus n. And again, math is all about consistent patterns. So when we were multiplying, we wound up adding the exponents. Here we're dividing, so it kind of is logical that you would subtract the exponents. Okay? All right, now let's go ahead and take a look at just a few expressions here. All right, so here we're needing to simplify using the rules for exponents, and then we need to evaluate the resulting expression. So here we have a 3 as the base on both of these, and it's multiplying So that means we could add exponents. So that's going to be 3 raised to the 8th power. I'll come back and evaluate those in a minute. I'll grab a calculator. Okay. All right. Then on this one, the way I would think about this one, using the rules, you would have said 5, I could subtract the exponents, I'd get 5 to the negative 2, but it's not considered simplified if you leave a negative exponent, so we would then go and do 1 over 5 squared. Okay. And then I'm going to show you another way that I would do that one. Okay. And then the last one, we have a power being raised to a power. That exponent is splitting, that parenthesis is splitting those exponents. So on that one, the rule would be that you could multiply exponents. So you get a 2 raised to the 12th power. All right, now 3 raised to the 8th power. Okay, that's going to be 6,561. And you do want to make sure you know how to do exponents on your calculator. So like if you're trying to do 2 to the 3rd on my calculator, I put in the base, then I find this button, it's on the left side of my calculator, and then I put in the exponent. You need to check your calculator. You need to make sure you know how to do it. There are calculators where that is reversed, so just test it. This should equal 8. So try that. Try 2 raised to the 3rd, make sure you know how to do it, and make sure your calculator gives you an 8. So this is one button you see a lot, and then there's another one that looks like that, and then some calculators show something like, I can't remember if they use an N or what, but they have like a, I think they do, I think it's an X, and then it'll have like a little box right there. Okay, so figure out how to do that. All right, so the second one would have turned out to be 1 over 25. All right, now when I'm doing that one, like I don't memorize the rules on any of these. What you really should do so that you're not just memorizing rules is just think. You don't necessarily write it, but think 3 3s and then 5 3s, right? So I know I'm going to have a total of 8 3s, okay? Well, when I do that here, what I'm thinking is there's 4 5s multiplied together on top and 6 of them on the bottom. So that means 4 of them are going to be able to cancel out. Don't have 6 yet. 4 of them are going to cancel out, but you notice there's 2 left on the bottom. So when I do it, I kind of don't really use the rule. I kind of think about the expression. Like I think about 4 5s on top, 6 5s on the bottom. There's going to be 2 extra 5s on the bottom. So I get to right there, and then I work it out. Okay? Right, and then on this one, I know I'm going to multiply because I'm kind of picturing how I'm going to have 3 2s times itself 4 times. So I'm kind of picturing 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I can kind of imagine why it's 2 to the 12th. And then I can evaluate that by doing 2 raised to the 12th power, and that one turns out to be 4,096 when I'm finished.